ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಮೈಶೆಲ್ ಡಾಕ್ಟರ್ ರಂಜನ್ ಸ್ವಾಮಿ, ಅಸಿಸ್ಟೆಂಟ್ ಪ್ರೊಫೆಸರ್ ಆಫ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್. My lecture on derivative of an arc length, session 47 in polar coordinates. First, I will go to derive an expression form arc length in Cartesian form. Now look at this diagram. Let the equation of the curve be given in Cartesian form y equals fx. Let P and Q be two neighboring points on the curve. Let A be a fixed point on the curve from which point the length of the arc is measured along the curve. Let the arc length AP equals S and arc length AQ equals S plus delta S. Thus, arc length PQ equals delta S. From the figure, PQ square equals PL square plus LQ square. Now PL is here delta X and LQ is delta Y. These are nothing but small increment with respect to X axis and Y axis. Now call it as equation number 1. Now if the point Q goes to P along the curve, then delta X goes to 0. Thus we have limit delta X goes to 0, chord PQ by arc PQ equals 1. Now we call it as equation 2. From 1 it follows that the chord PQ by delta X their whole square equals 1 plus delta Y by delta X their whole square. That means on dividing throughout equation 1 by delta X we may get this. Otherwise the left hand side of the equation multiply and divided by arc PQ, then we may get this one. And also taking as delta X goes to 0 and using equation 2, we may get ds by dx their whole square equals 1 plus dy by dx their whole square. Otherwise, if we put the square root on both sides, it follows that ds by dx equals root of 1 plus dy by dx their whole square, which is a formula for the derivative of arc length with respect to x. Now similarly, we may get ds by dy equals root of 1 plus dx by dy the whole square, which is a formula for the derivative of an arc length with respect to y. Next, we'll go to derivative of an arc length in parametric form. Now look at the two curves. Let x equals f of t and y equals g of t be the parametric form of the equation to the curve. We have from the figure pq square equals delta x whole square plus delta y whole square on throughout divided by delta t. Now you may get this one, and taking as a limit delta t goes to 0, that is as on q goes to p, we get delta t goes to 0 of the left hand side become ds by dt whole square and right hand side become dx by dt whole square plus dy by dt whole square. Otherwise, ds by dt equals root of dx by dt whole square plus dy by dt whole square. This is a formula for the derivative of arc length with respect to parameter t. Now look at the note. The angle made by the tangent to the point P to the curve y equals fx with the x-axis is xi. Thus we have dy by dx equals tan xi. Now we know that ds by dx equals root of 1 plus dy by dx whole square. Now if I take the substitution here, we may get ds by dx equals secant xi, and also ds by dy equals root of 1 plus dx by dy whole square. Now you are taking the tangent for this equation, we may get root of 1 plus cot square xi, that is nothing but cosecant xi, that is ds by dy. Hence we have some useful results. dx by ds equals cos xi and dy by ds equals sin xi. Squaring of these two and summing, we may get dx whole square plus dy square equals ds square. Next, we go to derivative of an arc length in polar form. Now look at this diagram. Let the equation of the curve be given in the polar form r equals f of theta. Now let us consider two neighboring points P and Q on the curve. Let A be the fixed point on the curve where the length of the arc is measured along the curve. Let arc length AP equals S and arc length AQ equals S plus delta S. Now the difference, that is S plus delta S minus S, it gives the arc length PQ, that is delta S. Now we have limit delta theta goes to 0, chord PQ by arc PQ equals 1, call it as equation number 1. Now draw a perpendicular line, that is PN, from P onto the OQ. Therefore, from the triangle ONP, we have sin delta T equals, that is opposite side by hypotenuse side, that is Pn by OP. It follows that Pn equals OP into sin delta T. This OP is nothing but radius vector, that's why we take that is R. Hence Pn equals R into sin delta T. Again, cos delta theta equals On by OP. Therefore, On equals OP into cos delta theta. This implies On equals R into cos delta theta. Again, from the figure, we have NQ equals OQ minus On. Now, this OQ is nothing but R plus delta R, and On equals R minus cos delta theta. Now from this, if I take R is a common factor, that is 1 minus cos delta T plus delta R. Since cos theta, that means cos delta theta equals 1 when delta theta is very small. Therefore, from the triangle PNOQ, we have PQ square equals PN square plus NQ square. Now Pn is here, R square sin square delta T plus NQ is nothing but delta R, their whole square. Otherwise, it is nothing but R square delta T whole square plus delta R whole square. Since sin of delta theta equals delta theta, as delta theta is very small. On dividing delta T both sides and taking limit as delta T goes to 0 and using 1, we may get ds by d theta, their whole square equals r square plus dr by d theta whole square. On putting square root on both sides, it follows that ds by d theta equals root of r square plus dr by d theta whole square. This is a formula for the derivative of an arc length with respect to theta. Similarly, the formula for the derivative of an arc length with respect to r is given by ds by dr equals root of 1 plus rn into d theta by dr, their whole square. Note, we know that tan pi equals r into d theta by dr. Thus, ds by d theta equals root of r square plus r square into cot square pi. R square is a common factor, root of r square, that is r. Then remaining 1 plus cot square phi, that is cosecant square phi. If I take the square root, it becomes r into cosecant phi. Again, ds by dr equals root of 1 plus tan square phi. So this is nothing but secant square phi. So it follows that secant phi. Hence, we have two more useful results. sin pi equals r into d theta by ds and cos pi equals dr by ds. Also, squaring above these two results and summing, we may get dr by ds whole square plus r square into d by ds their whole square is equal to 1. Otherwise, ds square equals dr square plus r square into d theta whole square. So on the basis of this different form of the derivative of an arc length, let us take some problems. That is example 1. For the curve y equals a into log secant x by a, show that ds by dx equals secant x by a and ds by dy equals cosecant x by a, and also show that x equals a into z. Now solution for this, given that y equals log of secant x by y. Now differentiate with respect to x. This is a times 1 over secant x by x by a into inner function secant of x by a into tan of x by a again into 1 by a. Now we will cancel a and secant x by a. The remaining is tan of x by a. Now I will take this substitution in this equation. ds by dx equals root of 1 plus d by dx whole square equals root of 1 plus tan square x by a. This is secant square x by a. So to remove the square root, it becomes secant x by a. Again, ds by dy equals root of 1 plus dx by dy whole square. Therefore, equals root of 1 plus cot square x by a. Otherwise, it becomes cosecant x by a. Also, we know that tan xi, that is slope dy by dx, it is nothing but here tan of x by a. Now we will cancel tan on both sides. It follows that xi equals x by a. Otherwise, x equals a into xi. Now see example 2. Find ds by d theta for the curve x equals a cos theta, y equals b sin theta. Now it is in the parametric form of the derivative of an arc length. Now he has given x equals a cos theta, y is equal to b sin theta. Let us will take the differentiation. X is a function of t, that is minus a sin t, and y is a function of t, that is dy by dt equals b into cos t. Now take all these things in this formula. ds by d theta equals root of dx by dt whole square plus dy by d theta whole square. So here on squaring the terms, it becomes a square sin square t plus b square cos square t. Now example 3. Find ds by dt for the curve r equals a theta. Now given that r equals a into theta, now r is a function of theta. Differentiate with respect to theta, we may get dr by d theta equals a. Therefore, ds by d theta equals root of r square plus dr by d theta whole square. Now here we will take the substitution dr by d theta, that is a square. Once again from r square, from the given equation, that is a theta their whole square. Now here a square will be common. The square root of a is a, the remaining is 1 plus theta square. Next, find ds by dr for the curve r theta equals a. Now once again you have to differentiate this function with respect to theta. You may get minus a by theta square. Otherwise, the reciprocal of this one is nothing but d theta by dr equals minus theta square by a. Now we know that ds by dr equals root of 1 plus r into d theta by dr whole square. Let us take the substitution here and simplify. We may get here r cancel, a will be cancelled, remaining root of 1 plus a by r their whole square. Otherwise it become square root of r square, that is r square plus a square. So now let us see some multiple choice questions on the basis of the above ideas. The first one, find ds by dx for the curve y square is equal to 4ax. Now for this solution, The option is A. Second one, find ds by dy for the curve y equals a into cos h x by a. For the solution to this question, option D. Next, find ds by dt for the curve x equals a secant y equals b tan t. For this, option C. Next, find ds by d theta for the curve r equals log of sin 3t. It is in the form of the solution. R is a function of theta, therefore the option is A. Again, find ds by dr for the curve r equals 1 minus cos theta. So here also r is a function of theta, it is in polar form, therefore the option is B. So these are the books I referred to prepare the concept of this. Thank you one and all. Thank you very much.